Okay, kids, so we are on number 8, and hopefully this will be our final video. I'm going to try to get 8 through 13 done. In this particular problem, it says quadrilateral WXYZ is reflected over the line y equals 1/2 x minus 4 to form quadrilateral DEFG. So WXYZ turns into DEFG. What do we know about the two quadrilaterals? Well, the thing that you have to remember is that it is reflected. And the first thing that should come to your mind is that reflections are what we call those rigid figures. And because they are rigid transformations, so because this is a rigid transformation, we know that quad WXYZ is congruent to quad DEFG, which means all of their corresponding parts would be congruent as well. So we would know, for example, that angle W is congruent to angle D. We would know that side XY is congruent to side EF. So we would know that all of those were congruent. It does not matter that this says 1/2. It does not matter anything about that. We know that the sides and the angles are all congruent because it is a rigid transformation. So this is what we would know from there. So remember, that tells us all sides and angles, and of course those are the corresponding ones. Those are the ones that match up. Are congruent. The other thing that we know, remember we talked about this in the one that we went over in class, is that quadrilateral WXYZ is similar to quadrilateral DEFG. And that's just because your scale factor, your K, would equal 1, and you know that all the angles are the same. So the sides are indeed proportional. Moving on to number 9, reflect this circle right here, across the y-axis. We did a lot of y-axis in here. There was no x-axis. Obviously, it works the same way. I apologize that there wasn't any of that on any of these problems, and I'm not sure that there's going to be. We are supposed to reflect it, and then we are going to dilate it. So the first thing I'm going to do is reflect it. I like to reflect circles. Circles are easier for me because it is simply a 1, 2, 3 to the left. So I'm going to go 1, 2, 3 to the right. So if I just take that figure and that should be 2 up, 2 left, 2 down, and 2 right. If I simply take that figure and reflect it, that would be my figure, my image right there. However, but it also told me that I needed to dilate it with a scale factor of 2. Because my radius of this circle is 2, my new radius, the image radius, is going to be 2 times 2, which is 4. So this is my center. I'm going to go up 4. I'm going to go right 4. I'm going to go down 4, and I'm going to go left 4. And I know that's not a pretty circle, but there's no judging here. Moving on to number 10, and obviously if you need to pause this, rewind it, feel free to do so. If you have any questions, or you miss something, you can go back. And remember, if you have any questions, you can feel free to email me. Number 10, a translation is applied to quadrilateral CDEF, and it is turned into or creating C prime, D prime, E prime, and F prime. We are supposed to describe the translation. Translation means that I'm moving left, right, up, or down. So the first thing that I have to look for, and I'm going to look at F right here. If you look at that F compared to this F has that little prime, so that means that this one right here is my image. So how do I get from this F right here to this F down here? The first thing that I do, if I look at X, remember we let this represent XY turns into AB. Well, in order for that to AB, remember we did XY turns into X plus or minus something and Y plus or minus something. some number. So that's what has to go. This is my A and this is my B. In this case, the x goes to the left 1. So this is going to be x minus 1, and it goes down 2, so this is going to be y minus 2. In number 11, we are looking at square ABCD, and we are told it's transformed to create A prime, B prime, C prime, D prime. So this one is my pre, and this one is my image. So how in the world did I get there? It says select all, that's important, we got to look at all of them, of the transformations that could have been performed. If I look at the first one, it says a reflection over the line y equals x. So if you want to, you can go ahead and sketch the line y equals x to see if that's true. Remember, we're at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. So I'm going to go ahead and sketch. Oops, I want to make sure that I have that lined up. Sketch that line. Can it be a reflection over the line y equals x? Well, remember, in order to find that, we would have to count. So I'm going to count over 1, 2, 3, 4, and go down 1, 2, 3, 4. If you check that for all of those points, it does indeed work. Remember, we can also think about it as I'm going to fold my paper over on that line. Is it going to match up? C and C prime, A and A prime, so it is indeed going to match up, so I'm going to go ahead and circle A. I'm going to move on then to part B, and it says a reflection over the line y equals negative x. Well, if I think about that, y equals negative x is this way. Y equals x is this way, y equals negative x is this way. Remember, when you have a reflection, it has to go from this side to this side. Notice that this flip-flops this way, so that is not one of my options. I am not going to have something here, or I don't have something here that reflects over both, that can reflect over both. It's not going to work that way. That would have to be a double, a multiple transformation. The next one I'm going to look at is a rotation 180 degrees counterclockwise about the origin. In order to do that, I am going to go ahead and write down what one of my points is. I am going to use the point B prime, and B prime after I rotate it would be 3, negative 1, 3, negative 1. I'm going to go ahead and rotate my paper counterclockwise, so that means left twice, 2 times, left, so once, twice. And when I do that, I'm going to check that point B. So when I look at B, which is this one right here, is that at 3, negative 1? No, it's at 1, negative 3. So therefore, it cannot be a rotation 180 degrees. Next, we have the point, next we have a reflection across the y-axis and then a reflection across the x-axis. So what I'm going to do is say, okay, I have my y-axis right here. I'm going to pick a point. So I'm going to pick a different point this time, and I'm going to use C. And if I look at C and I reflect across the y-axis, so here's C right here, and I go across the y, it's going to be right there. The next thing that it wants me to do is reflect across the x-axis. Okay, sorry, I had to pause that for a minute. I don't know if you can tell or not, but I'm going to look at the reflection across the y-axis. So I reflect C across the y-axis is going to be here. When I reflect across the x-axis, that does indeed work. But I'm going to be real careful about that because of where C is located. The reason that I avoided C last time is because of the fact that it is 1, 1, and 1, negative 1, and it has those. So I'm going to look at point D instead. And when I reflect across the y-axis, if I look, I count 1, 2, 3. For D, so 1, 2, 3 for D. D prime is going to be right there. Okay, D prime is going to be right there. In order to then reflect the other way, remember this is D, when I reflect over the x-axis, this point right here should be D. It's not, it's B, so that one does not work either. So sometimes, like I just demonstrated, I would definitely not do what I did here and pick that C. It's a bad point to pick. I would pick one of the other points like B or D because you don't have those doubled up numbers. I would not pick A either because A is -3, 3. So I would pick either B or D to try those and to attempt to do those. The last one that we have to look at is a 270-degree rotation clockwise. So 270 clockwise, that's 3 times to the right about the origin, and then a reflection across the y-axis. So again, the first thing I'm going to do is go ahead and pick one of those points, and I'm just going to look at one of those points. Okay, so this, I'm going to go ahead. I think I had my paper turned. Sorry, I had to pause it again. So I'm going to go ahead and turn my paper. It was 3 times to the right. And when I look at this, these points right here, A is going to be -3, -3. B is going to be -3, -1. C is going to be -1, -1. And D is going to be -1, -3. When I rotate that back and I plot those points, which I'm going to do real quick, that's -3, -3 is right there. That's your A. B is that is actually B. Sorry kids, it's late. Your A is down here, so there's my A prime. C prime is right here, and D prime is right here. Now, the next move is a reflection across the x-axis. I'm sorry, the y-axis, which would be this axis right here. I know I'm making a mess out of my paper, but that's okay. Better to draw than to guess. So look, and you've got C is 1 and 1. B is 1, 2, 3. 1, 2, 3. D is 1 and 1. And A is 3 and 3. So answer E is also one of my answers. So your answers here should have been A and E. On the last page, I'm going to try to get through this in the next couple minutes because I only can do 15 minutes per video. On the last page, we have square ABCD is shown on the coordinate plane. Points E and F are midpoints of their respective sides. So you've got points E and F. That being said, we're supposed to, again, select all that map the rectangle onto itself. So if I look at this particular question, it says a 45-degree clockwise rotation about the center. So if we take this and we rotate it 45 degrees. Now remember, this is a square. It is a regular figure. Okay, it is regular. So because it's regular, we're going to take the 360 and divide it by 4, and that gives us 90 degrees. So it cannot be that 45 degrees. A 90-degree clockwise rotation around the center. Yes, that is 90. Remember, our multiples would be 90. 90 times 2 is 180, times 3 is 270, and then obviously 360. So those are the only rotations it can be. The next thing that it tells us is a reflection across AC. AC is right here. That does work because, again, it is a regular figure, so those sides would match up. If I reflect across there, that would also work. If you need more practice on these problems right here, kiddos, go back to that website that we did with mapping. It is linked on to Classroom from the day that we did mapping. The very last question on here says, which transformations produce images that are congruent? Remember, they have to be congruent. That would include the very first one that we did of translations. Then we did reflections, and then we did rotations. So you have any of these three. You can also say any combination, so any combo of those oops, you couldn't see that, of those 3. So it can be any of those 3. Hope this helped. I'll see you on Wednesday.